one thing that was not in those notes was the reflections, but that's just the same old stuff as it was for polynomials, right? So if it happens inside of here, then it's affecting the x, right? And remember that x lies. And so when we're looking at reflections, if I'm going to change the sign on x, that's a reflection in y. After I process the x and then I change the sign, then that's affecting the y, which means it's a reflection in the x. But anything that's happening to the x inside of these parentheses, it's always the opposite. That's why if it's plus something, we move to the left. If this is being multiplied by 2, it's a horizontal compression because we're actually multiplying by 1/2. So remember, this right here for trig tells you how many cycles. So within a normal 2 pi domain, like from 0 to 2 pi, instead of having 1 cycle, it has 2 cycles. So in order for it to go twice in that 2 pi, it has to be squished together so it goes faster. Does that make sense to you? So this is the number of cycles, but then that changes the period because it's squishing it together. Okay, so let's look at what's happening with these. So I do have a negative, so this is a reflection over what? X. So this is the x-axis. So is there a horizontal stretch or compression? Yes, and so it's 2 times x, so it is 1/2. What is your amplitude? 1, because it's always positive, and it's not 0, because that number isn't 0, and it's not that it doesn't exist, it's just 1. Yeah, if you finish the beige and green ones, you may want to, there may be some things you need to adjust, because I did not get to talk you through some of these specifics. All right, so then how do I figure out the period? It's, okay, what's the normal period for cosine? 2 pi, or 360, but since we're using x, we're going to think radians. So it's 2 pi. This is your b value, so you divide that by b. So 2 pi divided by 2 gives me just pi right there. Your phase shift is basically your horizontal shift. Okay, it just has a different name. So are we shifting it left or right any? No. So my phase shift is 0. Do we have a vertical shift? 1. Okay. All right, so then do we have a reflection in number 2? No, so there is none. Is there a horizontal stretch or compression? Yes, this is 2 times x, right? So that's really 1/2. What's the amplitude? Five. Yeah, that's okay. 5. All right, so period, what's the period? Pi. Okay. Is my phase shift negative pi? The phase shift is the one where you may have to do a little bit of work here, because you cannot just look at it in the unfactored form and pull the number out of there. This is y equals 5 times the cosine. Then you have to factor out that 2. Okay, and the x or the theta needs to be positive. So sometimes you have to factor out like a negative even. But this is factoring out a positive 2. That leaves me with x plus what? Pi halves. Good. All right, so then that means that my phase shift is what? Negative pi halves. Good. Do you have a vertical shift? No, it is 0. So even if you get the hang of this, I want to run through these quickly because then you have some examples in there so when you come back and it can be fresh on your mind. All right, do we have a reflection? Yes, and it's happening inside the parentheses, so that's a reflection over what? The y-axis. Good, thank you. And then horizontal stretch or compression? Yes, it is a stretch because that's 0.5, which is really 1/2, which means I'm multiplying by 2. What's your amplitude? 3. Good. What about your period? Okay, so let's look at this. First of all, we've got theta, which means what? Degrees or radians? Degrees. And again, like I said, that's not like a really hard and fast rule, okay? That is something that I think that Ms. Rice just kind of decided along the way that both things get presented to you and so that there's not a confusion, because you have to know one way or the other when you work this problem, right? So instead of having to clarify every time, we're just going to kind of go with that unless you're specifically told otherwise. It's just an easier way to keep it ironed out. Okay, so we're looking in degrees because it's theta. But this is tangent, right? What is the normal period for tangent? Pi, right? Not 2 pi. So it's just pi. And then the b is 1/2. So if I'm going to multiply, or if I'm going to divide by 1/2, I'm really multiplying by 2, right? So it's 2 pi, or since this is in degrees, that would be what? 360 and not 720. Okay, so everybody understand why it's 360 and not 720? All right. And then, do I have a phase shift? Am I shifting left or right? No. So it's 0, and then this is 4. So watch out for tangent. When he pops up, he can mess. Oh, and then you know what I did? Because I wasn't even paying attention that it's tangent. Here where we have that 3, 3 is still the answer. But there is not an amplitude. But A does equal 3. It's still important that A is 3, but it's not the amplitude. It doesn't exist for tangent. I wasn't even paying attention to tangent until we got to the next part. Because when you're doing that, usually that point right there where it's at 3 pi fourths negative 1, that 3 makes a difference because that would change that to a negative 3. So it's still a stretch, it's just not the amplitude, because that's not a thing that you can actually measure. Does that make sense to you? So it's an important number, but it's not officially the amplitude. All right, do we have a reflection here on 4? No. Okay. Horizontal stretch or compression, what is it? 1/4, right? Because it lies. Do we have an amplitude? Yes, it's 5. All right, and are we in degrees or radians? Degrees. And so this is cosine, so I take 2 pi and divide it by radians. See, that's okay. I know, I heard you, but I'm just like, yes, I know. I'm going to stop asking y'all questions. I'm just kidding. All right, so it's in radians, but it's 2 pi. 2 pi was in my brain at least. 2 pi, but we're going to divide by 4, right? And so 2 pi divided by 4 is what? Pi halves. Okay. And then I have to factor out, so y equals 5 times the cosine of 4 times x plus 5. So it's okay that there's not like a pi in there. That's fine. It does not always work out that way. So my phase shift is negative 5. And do I have a vertical shift? Yes or no? No, so it's just 0. Everybody good? All right, do I have a reflection on number 5? Yes. X or y-axis? X. All right. Then horizontal stretch or compression, what is it? Okay, it is a stretch, and what's the number? 3/2, yeah. Nothing complicated, it's just a reciprocal, just like 1/4 is a reciprocal of 4. And do we have or what is the amplitude? 1. And then my normal period for sine is 2 pi. I'm going to do what with it? Divide it by 2/3. So what does that give you? How do you divide by a fraction? So it's 2 pi. I have to divide by 2/3. That's the same as multiplying by 3/2, right? So it's 3 pi. Yes. Fractions making your brain hurt a little bit. All right, so then I have to also factor this out. So this is going to become y equals negative sine of 2/3 times x. All right, so I've got pi 6 that I also have to divide by 2/3. So what's that going to give me? Pi 12? So just work it out. Let me see. Let me move down here if you're not so sure. Aren't you, when you're factoring it out, aren't you dividing? So if I'm going to take pi 6ths and I have to divide it by, what was it, 2/3? Which means I'm multiplying by 3/2, right? 3 goes into 3 once, twice, pi 4ths. Yeah. If, you know, it's sometimes even simple fractions in your brain, you're a little unsure, you're afraid you're going to do it quick, just jot it down and it's no big deal. So plus pi 4ths, and then minus 3. We're going to have room there. So then my phase shift is what? Negative pi 4ths. Good. And my vertical shift is negative 3. I'm looking at the wrong one. It's all good. All right, do I have a reflection here? No. And my compression, 2, because it's 1/2, so the reciprocal is 2. Do I have an amplitude? Yes, and it is 1/4. This is x, so we are in radians. I'm going to answer my own question before I agree to the wrong thing. It's okay. The wrong thing comes out of my mouth all the time. So I'm in radians. My normal period is 2 pi. So that means this one is going to be what? 4 pi, because I have to divide by 1/2, right? And then here, to factor this part out, this is 1/2 times x minus what? 2 pi. That means this is a positive 2 pi, and this is 6. Yes? Did I do something wrong? Not 2 pi. Oh, what? Oh, it's -6. Oh, it's -6. Was that the only thing you were confused about? You had like a weird look on your face. I was making sure. Okay. We good? It's -6. Thank you. All right. Reflection here, where? What's reflection in? X-axis. Horizontal stretch or compression? What is it? 1/2. Good. Do I have an amplitude? No, I do not have an amplitude, so the answer is none, but I do think it's important for you to recognize the A. What is it? 3, because that's still an important number for you when you're graphing, even though it's not officially the amplitude. All right, so then what is your period here? Pi halves, good, because your normal period for tangent is pi. You're going to take that and divide it by 2, so that makes this pi halves. Very good. Tangent has to be difficult. He has to be different. So 2 times x minus 3, right? So your phase shift is what? 3, and it's positive 3. And then do we have a vertical shift? No, so 0. We do, it's just 0. That's weird. Okay, so now these work backwards. So we know that it's y equals. There's no reflection here, so I don't have to worry about a sign. And my amplitude is 1, and I don't have a horizontal stretch or compression, so this is just going to be cosine of, now I'm in degrees, right? And this is 180 right here. So if this is 180, that's my period. What's the number that goes right here? 2. Because the normal, and you can think about it this way, you can do it mathematically, or your normal period is 360, okay? If it's half of that, it's 180. That means it's going to happen twice within there, and the B actually represents the number of cycles. So we have 2 cycles happening, and then we have to open our parentheses because we have a shift there. And this is x or theta? Theta. Sorry, I need my ringer on, but apparently somebody's doing a lot of calendar invites. Okay, so theta, thank you. And then what comes after that? Minus 60, good. And then close my parentheses, plus 4. So really the only thing you have to kind of think about when you're doing that from this information is this number right here. The rest just kind of get substituted in where they belong. Okay. So let's try this one. We're doing sine. So I get y equals. There is no reflection, so I don't have to worry about a sign for sine. My amplitude is 2, so that comes before my sine. So 2 times the sine. We're in radians, so that means we're going to use an x. Okay. So this is 2 pi thirds. That's your period, right? So how many times would this repeat itself in your normal period of 2 pi? 3 times, right? Because don't you just take the normal period and divide it by 3 anyway? That one kind of came out nicely so you didn't have any weird fraction stuff. But the way you get this number right here is your normal period, which is 2 pi, divided by the absolute value of b. So if this is 2 pi over 3, then b has to be 3. Get 3 times x, then what? Minus pi, close, close, minus 2. And if you were going to simplify this, the only thing you would simplify is make that 3x minus 3 pi. And then 2 theta minus 120. But leaving it like that for right now is fine. That's really the more useful way to look at it anyway. But if you multiplied it in, that's okay too. Don't worry about go back and changing either one of those. We all good? All right, so now this one's tangent, so we might have to think just a little bit more on some of it, not mess this stuff up. So we get y equals. This is a reflection in the y-axis. So does my negative go right here? No, it's going to change on the x part of it, right? And then under amplitude, this right here is, it says 3. There's not technically an amplitude, but a equals 3. So this is going to give me 3 times the tangent of, now we're in radians, right? And I know that now this has to be negative. My b is going to be negative because there's a reflection in the y-axis. My normal period for tangent is what? Pi. And the way you get your periods here are to take your normal period, which is pi, and divide it by b. So what would b have to be? 1/6. Good. So remember, that's the number of cycles. My normal period is pi. There are, 6 pi is stretched out there, so that's going to be only going to 1/6 of it for each pi. Then this is, open my parentheses, x minus what? 2 pi. Close, close. Do I need to do anything else? No. Okay. We good? Yes, sir. You don't have to right now. If you did, that's great. You need to be able to recognize it. But right now, I'm going to go with, it's fine right now. Okay. We good? Any questions on that? Does that help a little bit? Answer some things maybe? Okay. Good, good, good. All right. Now we're going to graph. And we may not get through all of the graphs today, which is fine. I mean, because if I got to stretch things out, whatever. But I will tell you, tomorrow we have testing, and Wednesday I'm not going to be here again. So what I'm going to do, since you would have to do this from a video anyway, is whatever we don't get done on this, we may finish, I'm not sure, but whatever I don't get done on this in class today, I'm going to finish on a video so that you can get this taken care of. And then if I put the due date for the homework to be Wednesday, if you're not ready to turn it in by Wednesday, it's okay. No, when it's tangent. When amplitude is none, tangent does not have an amplitude, because the definition of amplitude is a distance type of thing. And you'll see, if you look at this tangent graph over here. Okay, so amplitude. Let's just talk about amplitude again. The amplitude on just y equals cosine of x is 1, because it's the distance from the midline, which would be the axis basically, to a minimum or maximum point. So that distance is 1. It's also half the distance from the minimum to the maximum, so half of 2. You can look at it either way. But when you go to a tangent graph, the distance from the midline to a minimum or maximum point, minimum and maximum do not exist. So although that a value still affects it and it's a stretch, it's not an amplitude by definition. Does that help? That's a good question. And that's why on the definition of it, it's for sine and cosine functions only. What I would suggest for these graphs that we are going to do is for you to grab a colored pencil out of the box. And if they're all junk, then they should be decent. But if they need to be sharpened, then you can go grab plastic sharpeners from the back, so that because we're gonna look at this graphing 2 different ways. Today we are going to graph by just actually looking at the points and understanding the graph, and then we're going to look at it point by point on Wednesday. And I'll do the video here at school, so it's not quite as wonky. We are here. These are our notes. Now, so here's the thing. Even when we did transformations for polynomials, we could transform it by a table and look at it point by point, or we could transform it by understanding the parent function and think about what's happening. So today, because these work out a little bit nicer than the next set we have, we're going to look at it as just specifically graphically and not necessarily worry about the table so much. And then we're going to look at it from a table view the next time we do it. Okay? So what I would suggest that you do, so that you have some key points there, because the key points are pretty simple, but not even worry about the table necessarily, just we're going to get them graphed on here, okay, the parent function. So you might want to do it like lightly in pencil and then do the real one in colored pencil, or dot it with your pencil for the parent function and then make it solid for the actual transformation. You just don't want to get too confused on it and make it, you know, both of them dark in the same pencil. You won't know what the heck is going on. For all of these, on the notes and the assignment, it works out nicely if you use each one of the little X tick marks right here to represent pi halves. Okay, so it'll work out on all of them. So we're going to start with, this is going to be pi halves, and then pi, 3 pi halves, and 2 pi. Okay. That won't work out on every single graph you ever do, but on all of these on the notes and all of them on the homework, if you're consistent that way, everything works out in a decent fashion. Okay, so this is a sine graph. So the first thing I'm going to do is I'm going to graph my parent function. And we are using each one of these as 1. Okay, so it's going to be a little bit squished, but this is my 1 and my -1. So for sine, this is 0, this is 1, -1, what did I do wrong? What does that not work out? Oh, that's right. Oh, that one's wrong, that's why. That's not 0. Oh, I skipped 0, that's why. I said it and I don't think I did it. I hit it the wrong place. There you go, that makes way more sense. I'm like, why is my graph not working out? There we go. So 0, 1, 0, -1, 0. And then I'm just going to put this little dotted thing in there like that. Okay, there's my parent function. So even though I'm not making a table, I am point by point going to think about what's happening with this graph. Is the x value directly being affected at all? Do I have a b or a c? Anything happening with x? No, it's not, right? So my x value is what it is. But what happens once I plug in my x value is the y value is being doubled, and then we add 1. So here's my first point. X doesn't get affected. But the y value, which happens to be 0, gets multiplied by 2. Well, 2 times 0 is 0. And then I add 1, so my new point is right there. Does that make sense? This point right here, I'm not going left or right at all compression-wise or translation-wise. But this is at 1. The y value gets multiplied by 2, so it becomes 2 instead of 1. And then I also add 1, so I end up right here at 3. That make sense to you? I'm moving to this third point. It's at 0, so same thing, 2 times 0 is 0, and I add 1. Bam, there we go. Here, I'm at -1. Times 2 gives me -2. And then I translate up 1, and I'm right back here at -1, which seems weird, but that's what happens. You end up back at the same place. Then without doing anything, thinking about, you know, the actual number and what's happening, can you already tell where that point's supposed to be? Yes, it's supposed to be right here, right? Because look at what's happening another way. What's the amplitude here? Amplitude is 2, right? And the vertical shift is 1. So I shifted up 1, right? So everything that's on the axis all gets shifted up 1, and instead of the amplitude being 1, it's now at 2. It's kind of a different way to look at it, right? So here's just this one cycle, right? Because the period didn't change, because I'm not affecting x at all. Then after that, you should be able to finish out the rest of the grid. If you just look at the pattern that's happening here, there should be a point here and here, right? And then this one's going to be up here, so I can finish that off. And then down here. And then up here. So you get the one cycle done from the parent function, and then you should be able to just fill in the rest from the pattern of what's happening since it's a periodic function. Any questions about that? So let's try this one. I'm going to do this again. Pi halves, pi, 3 pi halves, 2 pi. So this is cosine, right? So for cosine, looks like this. That should be something that you should be able to sketch in there very, very quickly and easily, parent function wise. Now, is your x being affected here? Yes. Okay. We don't have a stretch or compression, but we do have a shift, right? Are we going to the left or the right? To the right. And it's pi fourths. So if this is pi halves, pi fourths is like in the middle, right? So we have this point here. We're going to shift it. The x value gets shifted to the right, pi fourths, which is like halfway in between those little marks. And then that negative sign means that I have a reflection in what? The x-axis. So this point then reflects down to here. Take this point. It shifts over pi fourths and gets reflected. Well, it's very unexciting when it's on the axis. This point, we shift over pi fourths, and it's a reflection in the axis. And then you can just kind of see what's happening from there. Everybody okay with that? Is that simple enough? Just moving it over and looks the same. So then you can finish out the rest of those. Any questions about that? Tell me if it doesn't make sense. What's your amplitude here? 1. Amplitude is still 1, right? But we do have a reflection in the x-axis. And then we had a phase shift of what? Positive pi fourths. Just moved it over. Everybody okay with that? All right. Good. I should be able to get through at least the next two. All right, so we're here, we're at pi halves, we're at pi, we're at 3 pi halves, and we're at 2 pi. So this is cosine again. So get this drawn in there, just so I have something to look at. I feel like the reason I don't want to start with just the table of values and do that today, I feel like some of you get tied up in that table of values and you don't understand what's happening with the graph and how easy it is to just look at the graph sometimes. Sometimes when the numbers get a little bit weirder, it helps to think through the table and understand what's happening there too. So you do need to kind of know them both. But when there's simple basic stuff, just taking it from the parent function is way easier. All right, so my x value does not get, oh, shoot, we're in theta. What does that mean? Dang it. Degrees. All right, well, you know what? It's fine. We'll just pretend like that's an x. Did y'all already fill it in with pi's? Yeah, okay. We'll just make that x then. It's fine. It's all good. It's all good. We'll do theta on the next one. I wasn't paying attention. And I don't want to make you restart. When I did it on here too, I did it and then I had to erase it. I still didn't learn my lesson. Okay, but your x value or your theta value, that one we don't have a phase shift and we don't have a compression. So all that's happening is you're taking the value that you have. The y value gets multiplied by 1.5, so 1 becomes 1.5. And then we do what with it? Subtract 1, yeah, so I end up right there. So 0 times 1.5 is what? 0. And then you go down 1. Negative 1 times 1.5 is? Negative 1.5, and then you go down 1. And then really at that point, you should be able to fill in the rest of them. Your amplitude is 1.5, and then your vertical shift is negative 1, so it just stretches it up a little bit. Stretches it and then shifts it down. How's that? Theta means degrees. Remind myself before I mess it up again. All right, so we're still going to do the same spacing though. This will just instead be 90, 180, 270, and 360. That's really the only difference, so it's not that big of a deal. But this is tangent. Okay, tangent's a bit trickier. The parent part of that, you could look at it a couple of different ways, but your period is not, your normal period isn't 2 pi, it's just pi or 180. But it doesn't even go from 0 to 180. I mean, you can look at it that way, that's just weird, but we want to shift it over just a little bit to here. So here are your undefineds. That's why that understanding just the table of values there is important. This is 1 and -1 there. This is at 0. Okay, so from 90 to 180 in the second quadrant, tangent is negative. And between 90 and 180 right here, this is -1, this is 1. So here is your parent of the tangent. Now your x value is being affected here, right? Do we have a horizontal stretch or compression? It's a stretch, right? Because that is that's 1/2 being multiplied by theta, which means that we're actually multiplying the x value by 2, okay? So I'm going to take this value here, which is undefined, right? My undefined value is, the x value right now is 90. So when I multiply 90 by 2, what do I get? Yes, sir. Were you raising your hand? Oh. I get 180. So that moves here. Okay? This value, the x value is at 180. It's going to be multiplied by 2. Where does that x go to? 360, right? Then that negative, that means it's a reflection in what? The x-axis, which means since it's on the axis, that doesn't matter. Now I'm going to do the asymptotes and this point first, and then we're going to come back and do the other 2 points. So then I'm going to look at this asymptote, right? What's 2 times 270? 540, so that ends up right here. So here's my other asymptote. Okay. Now then this point right here, that's at 135. What's 2 times 135? Come on, what's 2 times? 270. All right, so the x value moves to 270, but I have a reflection, right? And that reflection is in the x-axis, so this point comes up here. So do you automatically know where your other point goes? Like without having to think through all that? If my graph is going to come in like this, isn't that other one going to have to mirror that over here? And you get that right there. That's why I said you want to, with the 2 colors, I know it might be a little confusing. Maybe if they're not both colored, it would be helpful, you know, if you just have a light pencil there. Now when you look at this, because this is periodic and it just repeats itself over and over again, you went 1, 2, 3, 4 to get to the other asymptote. So 1, 2, 3, 4, here's my other asymptote. Right in the middle of that is 0. Here's your 1. Here's your -1. Right? And then we can draw that in. Oh crap. I want you to try these on your own. I will finish this. You let me know if you have questions. These are not that bad. It may be helpful to have the last 2 examples, so I'll do that on a separate video and you can go and watch that. And then I will re-explain some things. You will have to do a video lesson again on Wednesday, and I apologize. But if I need to clear it all up, if you want to turn stuff into me, just stack it up and I'll come get it. If you're not ready to turn it in, that's okay too. All right? Have a great day. When I am out, though, if you need something, you can always text me, or you can go to Miss Archer or Miss Rice. Or Miss Ferris next door. She's good at this stuff, too. Or Miss Tremont. There's lots of teachers that can help you.